Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Malia Science.
Hey Dad, I got a science question for you.
What's that?
How do magnets work? Like, how are they magnetic?
That's a great question. Let's take a look at some magnets and how they work. They work with an invisible force called a magnetic field. Even though it's invisible, we're going to show you it using some iron filings. Come on, let's take a look. All right. To put it simply, a magnet is a rock or a piece of metal that can pull certain types of metal towards itself. The force of a magnet is called magnetism. It's a basic force of nature, like electricity or gravity. This means that a magnet does not have to be touching an object to pull it. Now, the magnet has two different poles. The blue side is the south and the red side is the north. And like sides, like these two south sides poles, are repelling each other. But when you flip it around, they attract each other. So a north and a south side will attract each other. Now this other magnet doesn't have a side, but it's being attracted to our north, so we know that must be the south. Now it's repelling our north, so that must be the north side of that magnet. So north and north push each other away. South and south push each other away. But north and south will attract each other. Now, a magnet isn't attracted to every type of metal, mostly just iron and cobalt and metals like that. So here's a piece of steel which has some iron in it, and the magnet is attracted to it. But this aluminum, little chunk of aluminum, it's not attracted. And that has to do with the way that the electrons, everything's made up of atoms that have these electrons running around their nucleuses really fast. And some are in a nice order, all going in the same direction. Those things are easy to magnetize. Here we got some little steel balls that this magnet can pick it up and line up all the electrons so that they all become magnetized. Some things, like paper, can't be magnetized. Now here we have some interesting magnets, and we have all the south poles at the top. And these south poles are just hanging out, pushing each other away. But we had one north pole, and oh look, they all want to go there. Oh, that last little south pole wants to go to the north pole, but it's attracted to it, but it can't get there because the other two south poles are pushing it away. So let's try this again. Let's try this, the bigger magnet there. There you go. All the south poles are attracted. But now let's flip this big magnet up. See, magnetism can be pretty powerful too. This can be so powerful. See the way they're pushing it away? Certain magnets can lift a train off a track. This lets the train run without friction. There we go. Lets it run without friction. It's called a maglev train, and it goes very fast. Now if we want to see this invisible field, this magnetic field, we put a magnet under a piece of paper and take some iron filings and spread it across the piece of paper, and you're going to see the magnetic field, how far it goes. You see the outline of the magnet? It's actually turning those little pieces of iron into magnets. It's polarizing them. These are temporary magnets. Yeah. All right, you can see there. You can see the poles on each side. You can see how strong the magnets is. Over to the right, the magnets aren't moving. Now, if I stick this magnet underneath there, we're going to see, oh, these must be like poles that are pushing each other away. And even the iron filings are pushing each other away because they became magnetized with the same pole. If I flip it around, now they're unlike poles, the north and south, and they're attracted to each other. All right, let's take another look at another magnet. One of our red and blue magnets up there. And don't worry, this stuff is pretty easy to clean up. All I have to do is run a magnet through it, and it'll clean up all that powder. Just like when maybe your parents burned something and it's got a lot of nails in it, they run a magnet through the fire pit afterwards. There we go. Just spread it a nice little sprinkle. Just a dash of iron filings. Not used for cooking, just for science. And we can see a nice picture of a magnetic field. Here we go. Which one of these? Okay, let's get the north. Now, we've mentioned north and south poles on these magnets quite a few times. And what else has a north and south pole? You're right, the Earth does, because the Earth is a magnet. And scientists don't fully understand why, but they think that the movement of the molten material, the melted rocks and metal in the Earth's outer core generates an electric current. And this current creates a magnetic field with invisible lines of force flowing between the Earth's magnetic poles. And some animals, such as pigeons, bees, and salmon, can detect the Earth's magnetic field and use it to navigate. Scientists, again, aren't sure how they do this, but these creatures seem to have magnetic material in their bodies that attract like compasses. It's pretty cool the way these animals do this, and they don't even have to wear these magneto helmets. Well, we've just scratched the surface of magnets, but that's all the time we have this week. But I bet you have a few magnets on your refrigerator that you can go and explore with. So find some magnets and see if you can figure out if you're comparing like or unlike poles, and just play around with them. It's really fun and it's safe to do. So long, Malia gang.
And may the magnetic force be with you.
Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Malia Science.
Science.